It's a hot one here in Vegas. You know, guys, when we get back from one of these test drives, we shake them up pretty good and they get a little bit dirty. Now, we don't go out and hammer on them, but we probably drive them a little bit harder than you would on a regular outing. You can see we removed the grill on this one because it was obstructed, and I'm going to show you that grill. Here's the grill we removed off the test drive vehicle. I think you'll notice that this is not only a reduced size opening on the grill inlets, but then we have this pretty fine screen mesh inside of those openings, and you can see how little white you can see coming through the grill openings, indicating that the majority of the airflow is just blocked off. We're in a mid-year JK, and I'm going to call that the 2011 because it has the new interior, but it has the old engine. We were going to take a test drive in this a couple of days ago, but it's been pretty hot here in Vegas. It's probably about 112 right now, which is what the dash is saying. Earlier the dash said 130. It wasn't 130, but our shop is out by Nellis Air Force Base, and it was probably 115 out there. With the air conditioning blasting going down the highway, this Jeep was not running, it wasn't overheating, but it was running too hot. We were running over 240 degrees, and it shouldn't do that. The fan was working really hard. You'll probably notice that this Jeep doesn't have a grill on it. The grill is not only an Angry Eyes grill where it has reduced openings for air to flow in, but those openings are then blocked with some kind of molded in screen mesh. So essentially the radiator fan has to suck through a straw to get air through that radiator. And remember, we're not just pulling in cool air to the radiator, we're pulling in air through the transmission cooler, which is hot, and then the AC condenser, which is hot. So the air getting to the radiator is hot. Then we restrict the grill so there's no natural airflow. We have a problem. So we pull the grill off. We're running much cooler. So we're going to do the test drive with the grill off, and when we get back to the shop, we'll give the customer some options with a grill. Now, a lot of you say my Jeep's not overheating and my grill is blocked, but the reality is the fan is taking up the slack. If I'm driving down the highway, bombing along at 70 miles an hour, and I see that fan at 60–70%, sure, the engine's running at 210, 220, air conditioning's cold, but the fan is working really hard. If you were to open the grill openings up, you're going to be bombing along at 70 miles an hour, and the fan's going to be running at 20%, while the natural airflow into the radiator is what's doing the cooling. And that's where you want to be. You don't want to make that fan work really hard. The Camaro SS fan can handle it for a while. It's a very high quality fan. It's sealed. It's an outrunner. It's a very durable fan. But if you got a DC brush fan that's not sealed, you're going to have a problem. That fan's going to wear out pretty quickly. So why not let the grill do what it's intended to do, and that is let air into the engine compartment. Why block it? Why reduce the grill openings? Why put screen mesh over it? Why block it with a winch? Why block it with driving lights and fog lights and license plates? Just let it do what it's intended to do. There's plenty of real estate in the front of the vehicle to put everything you want there. Following up on our last video about maintenance, we're going to talk about some post-swap concerns that you may have or we may have, and a lot of it's just common sense. There's going to be some rambling here just because these are my thoughts and there's nothing pre-planned, but I'm going to try to convey what we see after the swap, and sometimes issues and other times benefits that guys have after they do the conversion. Probably one of the biggest concerns I have, well, the two biggest concerns I have are cooling and electrical. Don't block your grill, guys, and this is really common sense. It's very easy to be lured into putting a license plate or lights or a stinger or a winch in front of your grill because it looks cool, but you're then reducing the efficiency of the inlets of that grill. With powerful fans like the Camaro SS fan and the JL fan, they will overcome most of the restrictions. However, you're making that fan work really hard, which is putting a load in your electrical system. The engine's running hotter than it probably needs to be, so just keep the grill clear. As I stated yesterday, this Jeep was running pretty cool with the Camaro SS fan, but when it got onto the highway about 75–80 miles an hour and it was 110 degrees out, air conditioning blasting, the fan was just working too hard, so we removed the grill. The second is the electrical system, and there's a lot of things you can do to the electrical system to screw things up. One of the most common, but probably the least understood to me, is the battery. This is a science well beyond this discussion. However, we have had nothing but problems with AGM batteries recently, and it's not just us. OE manufacturers are switching over to AGM batteries, but they're designing the vehicles for the batteries, and they are manufacturing the batteries to very tight specs. The manufacturers like the stop-start capabilities of the AGM batteries and the maintenance-free nature of the AGM batteries, so they do have some benefits, but you all know that they also have some downsides. Manufacturers are changing how the charging systems work. They're changing how their modules react to the chemistry in an AGM battery. But if your powertrain was not designed for an AGM battery and you don't get a quality AGM battery, then you might have problems. I'm not going to say it's a lot, but we've had a handful of throttle actuator control problems solved recently simply by removing the AGM battery. Guys don't understand it. Sometimes they don't believe it, but it does fix the problem. The other problem, as mentioned in a previous video, is check those battery cables. Mopar runs oversized terminals on some cables, and no matter how much you lean down on that 10mm nut and tighten it down, it's still loose on the terminal. So I prefer a good lead acid quality battery. So the first thing I would say if you're having some electrical gremlins is replace the AGM battery with a standard lead acid battery for testing. I've had AGM batteries drop cells where they're at 10 volts, but they're cranking the motor over great. So the customer thinks that there's nothing wrong with the battery, it's cranking the engine over, but the reality is it's running at a low voltage. After the battery and cables, I'm going to say aftermarket accessories. We're in an 11 Jeep, which is the old 3.8 engine with a new interior, and this Jeep doesn't have a whole lot of stuff. It does have some rockers and things for probably lockers, but some of the Jeeps I get into are just crazy with the amount of electronics they have. I've had Jeeps with so many electrical wires for rock lights and amplifiers and you name it, refrigerators and dual batteries. I had one Jeep from Canada that had 6 onboard batteries, power inverters. All that's fine and well, but just remember, you got to keep the engine performance system happy. So if you start tying all that stuff in, recently I've had a couple of guys with these aftermarket alternators, the ones that they use on the welders that are externally controlled. And before they even did the swap, they were having issues with these alternators and want to know if we can run them with the swap. Now, we have run those welders with the swap. There's always that risk that something's not going to work right, just like before the swap. And that's a pretty good caveat. If it works before the swap, it's probably going to work after the swap. If it doesn't work before the swap, don't count on it working after the swap. There's a couple of exceptions, like our cruise control system is very robust, and Chrysler's cruise control system is pretty fragile. Let's move on to suspension. I got a couple of Jeeps in the shop right now, and we've had many in the past where the customer tells me, oh, by the way, it has death wobble. And as many of you know, death wobble is almost as much of an art that it is a science. There really is no one single silver bullet that will cure death wobble, other than maybe a hydraulic ram. I've got one in the shop right now with 500 horsepower, a 3-link suspension system, and the joints are shot. So you get going down the road, you get on and off the throttle, you can hear it clunking, and the thing is darting left and right. And that's just downright dangerous with a 500 horsepower engine. So of course we're going to be replacing the joints, but this is something that you guys are using kits or have bad suspension need to consider, even if it's not a V8, is get that suspension in good working order. First, you want your roll center to be as low as you can get it, in my opinion. It is really cool to have a 6-inch lift and 40-inch tires, but you're getting off a freeway on-ramp really fast, or you have to make a sudden maneuver, and that high roll center can get you in trouble. But then I know a lot of you guys are crawlers. You got 40-inch tires for axle clearance, you're worried about your belly clearance, and just make it as low as possible. If you've never taken your Jeep off-road and you got a 6-inch lift, then there's probably something not right there. Make sure the suspension has been installed properly. Now, we don't see a whole lot of problems with the mid-arms that the JK comes with, but when guys put long arms in, we see all sorts of goofy stuff. The brackets are welded in crooked, or they're not welded in right, meaning guys don't take the bodies off and weld the brackets all the way around. We see rust. I have a Jeep in there right now, and we're replacing the frame because the frame is rusted pretty severely where the welds were. Now, when the factory builds these frames, they use a flux-based MIG, or metal inert gas welder, and there's some acidity to that. So when rust does start, it usually starts at the weld joint. In addition, some of the brackets were welded on, and because they didn't have access to the back sides of the bracket, they couldn't rust proof it, so the brackets are completely eroded. So just start with the frame, make sure everything's solid on the frame. And then of course the control arms, track bar, and all that, make sure the joints are good and they're tight. And when I say tight, a lot of guys think they're tight, but a track bar especially, the bolt has to fit really tight in the hole in the bracket and the hole in the joint. Because if there's any movement there, it's probably going to move, and then you might get death wobble. So make sure the hole isn't egged out or oval shaped, and tighten that bolt to spec. Do that with all the control arms. I've had a metal cloak suspension on my Jeep now for 10 years. About 3 years ago, I started to hear a little clink when I came to a stop, or a hard stop. And I called over to Metal Cloak and they said, hey, just retorque the control arm bolts, and I did, and the problem went away. Because even that little tiny insignificant amount of movement can cause a problem. Check your brakes carefully. Like I said in the last video, you can't believe how many caliper bolts we've had come in loose, or master cylinders that were low. We've had brake lines that aren't routed properly, especially in long arms, and they're rubbing or they're kinked. I get them where the brake locks up on one wheel because the steel line going to that caliper has been smashed and it can't return. So check the brakes. When you hit the brakes hard, well, here's a good test. Get your Jeep on a nice flat road, get going down the road, and let the steering wheel off for a second, and it should go perfectly straight. Now, get on the throttle hard and then off the throttle hard. It should still go straight. If that front end comes up and down and your Jeep darts left and right, you got a problem. You got torque steer, and you got to figure out why. That same torque steer is also going to be brake steer. So when you brake hard and the front end dives down, it's going to dart to one side or the other. So do that test, and if your Jeep doesn't pass that test, you got to think twice about putting a 400 or 500 horsepower motor in your Jeep, because maybe you're not driving it, maybe your wife's driving it, and she's not ready for that floppy suspension. And unfortunately, the suspension that articulates a lot, which is the goal of a lot of guys, and is all floppy, are the suspension systems that are the worst. Now, there's good compromises. If you get a good quality suspension system with variable rate springs and shocks that are valved properly, you can still get a lot of articulation and be safe on the road. I've had a couple of Jeeps come through the shop that we built years ago to find that the air filters we installed are still in there, never been cleaned, never been replaced, just caked with dirt and dust. Some of these guys are going to Johnson Valley. Johnson Valley is a very difficult place because it's not so much sand, it's silt. And silt has really small particles. I don't know what the micron reading is, but they're really small, and they'll bypass a lot of filters, and they'll get through the filter into your MAF sensor and contaminate the MAF and obviously get into your engine. So if you're going to run a place like Johnson Valley, get the proper filter. If you're the last guy in a wagon train of Jeeps and you're just eating dust the whole way, get the proper filter. You want a filter that's going to filter down to the micron level. You want a filter with a sock or a foam sponge around it, maybe an oil filter, but here's the thing about that. It's going to get dirty really quick, maybe on one trip. So be prepared to replace it. Carry spares. A lot of guys don't replace it. They don't want to clean it because you got to buy the kit and it's messy and etc. They don't want a throwaway filter. They want a re-oilable filter. So, just use some common sense. If you're going to be running off-road and you're going to be running a filter that's capable of filtering those conditions, get ready to replace it sometimes after every trip. And again, it's one of the most common issues we have when a check engine light comes on. The air filter is plugged and caked with dirt and the engine's running lean. Check your engine oil. I have a Jeep in the shop right now that blew up its Pennstar engine, 3.6 engine. It stuck a leg out of bed for you old hot rodders. That means that it threw a rod. It actually put a hole in both sides of the block. The customer was going up a waterfall and he found out later that the engine was 1.5 quarts low on oil. Another really important and neglected thing I find is coolant. Coolant, a lot of guys think you put coolant in the vehicle and it's good for the life of the vehicle, and I know that some manufacturers have advertised that, but it's not. You need to check your coolant. It's a lot more important to check the coolant level than the condition, because if there is no coolant, you're in more trouble than if there is coolant and it's dirty. So we use an expansion tank. We don't pressurize the bottle. Some manufacturers do pressurize the bottle. It does save a little bit of evaporative emissions from the cooling system, but at the end of the day, it only takes a minute to look inside of your expansion tank and look at the level. When the engine's warm, it should be about 1/2 to 3/4 of the way up. When the engine's cold, it's going to be at the bottom. Don't add. It's at the bottom because when the engine gets warm, the coolant expands into the bottle. That's why they call it an expansion tank. And then when the engine cools off, it sucks it back in. LSs and LTs are reverse flow cooling systems. Before the first start, pull the upper radiator hose off the radiator. Hold it as high as you can get it and fill it with coolant. You're going to fill the block up with coolant. It might take up to 1.5 gallons, sometimes 2 gallons. The reason is if you were to fill up the radiator is trying to push the coolant through the lower hose through gravity, but there's a thermostat at the bottom hose. So it's not going to let it into the engine. You're going to start the engine up and there's going to be no coolant flow. The water pump's going to be running in air. The engine's going to get hot. The fan's going to turn on. The fan's going to blow cold air. You need to fill that block up. After you fill the block up, put the hose back on, fill the radiator up, start the engine. Let it sit there till the thermostat opens. You will see bubbles coming up through the radiator neck. Let the bubbles go. Keep filling it up until it stops. Put the cap on, run it for a while. Once the fan turns on, you want to feel that upper hose get hot and then hot air come out of the fan. If cool air or warm air is coming out of the fan and the upper hose is not hot, you have an air bubble at the top of your heads. And this is a very common problem. I'll give you the scenario. You've had your Jeep for a year, 2 years, you've never checked the coolant. Every day, a little tiny bit of evaporation happens. Coolant bottle goes dry, the engine cools off, and it sucks in a little bit of air. Same thing happens the next day. Same thing happens the next day, and you never check your coolant. Eventually, enough air builds up on the top of the heads to where the water pump starts to cavitate. Once the water pump starts to cavitate and isn't pumping water, your coolant needle is going to shoot up, and you're going to call me. And the first thing I'm going to say is, have you checked your cooling system? And you say, well, I haven't checked it in 6 months, maybe a year. Check it every other time you go to a gas station. We all know that radiators leaking in JKs is a common affair. Our new dual header radiator does seem to have solved the problem, but still, radiators get old. 3, 4, 5 years old, an aluminum radiator flexing in a JK, it's going to start to seep. I want to do a video on radiators, so I'm not going to get into this in depth, but just know a plastic aluminum radiator like the stock radiator in your JK is capable of flexing with the chassis a lot better than a welded together aluminum radiator. The stock radiator has plastic tanks, rubber seals, and it's crimped. An aluminum radiator is like a solid brick, and aluminum, as most of us know, doesn't like to flex. Metal will flex better, or ferrous metals will flex better than aluminum, because aluminum tends to crack. So when you have a JK that weighs a lot, it's got a roof rack, you do heavy off-roading, the chassis is flexing and twisting, it's going to tear that radiator up, usually the tube to header joint. So the dual header radiator puts 4 headers onto the tank where the tube goes in, and that has helped tremendously. We also use spring mounts on the top, so as the chassis flexes, it allows the radiator a little bit of relief. So the JK is the perfect storm for cooling systems. Here you have a chassis that flexes a lot. We require a bigger radiator because these JKs are heavy. A lot of guys put stuff in front of the grill, as we talked about earlier, so the fan has to work harder, the radiator runs hotter. You're twisting and flexing that radiator constantly because the JK is an off-road vehicle. Then you put all sorts of weight and roof racks and things onto your JK, which make it flex even more. So run the spring mounts, also run a conditioning tablet. GM and Bardol's both make a conditioning tablet that isn't a stop leak. Well, it is a stock leak. The reason we use it is we want to coat the inside of that aluminum radiator so that it's protected from corrosion and electrolysis. And electrolysis is a big issue, especially if you have a lot of electronics like some of the JKs we work on. Electrolysis is voltage that can be built up in your cooling system, and it'll start eating away at the metals in your cooling system. You can take a standard voltmeter, put it on a low scale like 2 volts, and measure the voltage inside your cooling system. You don't want to see it over 1.5 volts. You don't want to see it over 0.5 volts. You want to see it as close to 0 as you can get it. If you're seeing it up there, then you got to figure out why. You can ground the radiator housing, or you can add a sacrificial anode, which we used to do in the old days, so that metal will get eroded before the parent metal gets eroded. But really a better solution is to find out the cause of the electrolysis and fix it. Now, believe it or not, the starter motor can be a big cause of electrolysis, because that's where essentially the 2 points of the battery meet, your positive, your power distribution, and your ground distribution. And an old GM engineer told me that they had problems with poorly manufactured starter motors in the aftermarket, causing the cooling systems to erode and cause leaks. Try explaining that one to your customer. This video is getting a little long, so I'm going to stop here, and we're going to follow up again with another after swap video. But what we discussed in this video are the main concerns that I have. And if you have a V8 JK, and it doesn't even matter if it's a Hemi or whatever, just use common sense and maintain it properly after the swap, and your Jeep will run properly for years to come.